Welcome to the Pledge Pros podcast, a podcast dedicated to unmatched value and unwavering support for our customers and the community at large. Today, we have two Upkeep ambassadors, two of my good friends we've met at SMRP. We're always chopping it up. They know what they're talking about. We have Matthew Knuth from SPM Instrumentation, and we have Howard Penrose from MotorDoc LLC. These two are my boys. They're absolute crushers. And today, I wanted to talk about two very, very popular things in our world of maintenance and reliability, which is AI, artificial intelligence, and sensors in general. Matt is here to speak on sensors. He's a trusted confidant of mine that I take a lot of advice from when it comes to sensors. And of course, we have Dr. Howard Penrose, who is a coder, motor guy, everything you can think of. And he will be helping us with the AI side of these things. So welcome, fellas.
Thanks, Ryan.
Hey, good to see you.
Awesome. Awesome. Yeah. So this is my first question. I'm just going to drop a big bomb on you guys, which is, will AI in our lifetime replace the human experience when it comes to inspecting machines? Go ahead, Matt.
My profound answer is no, it will not. At least not in my lifetime, maybe in my children's lifetime, who knows? But I'll say this with that: if AI and machine learning and wireless sensor technology is being deployed by companies merely to replace people, then they're going to be in a lot of trouble. Currently, I don't think there's enough AI or ML to achieve that goal.
Agreed. Howard?
I'll go a step further and say that I've been hearing not just a lot on AI, but self-healing equipment and yes, and there are some variations of equipment that will help carry you past a failure based upon what they call self-healing, but really you can't replace the knowledgeable technician or the maintenance technician who's doing the repairs. The more I see the addition, as a matter of fact, the more severe I'm seeing the faults.
Right. The way I think of it too, guys, is as a human, as you guys have been technicians, I've been a technician, right? When I walk up to a machine that is experiencing some form of failure mechanism, I'm doing the human experience is sensing so many things at one time, right? And I'm able to draw upon experience and insight and intuition and the human experience to evaluate a machine. I don't know a lot about AI, but I'm assuming, and Howard, I'll ask you, AI in a nutshell, in our current form of using it in maintenance and reliability is what?
Basically, it's a table. So it's a decision tree. I mean, there's variations of it, some making more complex than others. The original idea of AI heading towards what we used to call it machine learning. Now we call it AI. Towards what we used to call AI, we now call AGI, generalized intelligence, right? Or artificial generalized intelligence. Neural networks were a path for that, which is just a complex tree with percentages or probabilities that a branch is correct, right? So you come down and you say, okay, this is 66% chance, and this is 30% chance, and this is 1% chance, and so on. And then it branches off until you come to a or a series of conclusions in the end with a probability associated with it. But the original idea was supposed to emulate human neural pathways. And while they've become more and more complex, and our machine power, meaning that what I used to have to use a university computer for, I can now use a laptop for. Right. So I have so many cores and everything. That was 2007. It's not there yet by a long shot. It's too logical.
Right.
We try to get again, I'm going to call it machine learning. What we're calling AI from a marketing perspective is really machine learning, right? Even when you talk about, to use a brand name, ChatGPT 4 or the 4.5 or 5, we're not sure which one's coming out next. But you're talking about basically a machine learning model. And that's what they call it in the technical papers. They don't call it AI. Everybody, that gets their hands on it, they put their wrappers around it and they refer to it as AI, right?
Right.
So yeah, we're a long ways off it actually taking over human intelligence. It's a great tool for doing very specific tasks, especially repetitive tasks, right? Or the boring stuff.
Right.
But no, we're far from that. It's explicit, whereas people are implicit.
Right.
And
The thing about it is, going into, I'm going to go to Matt next here, but like going into a troubleshooting evolution, right? When you're troubleshooting a problem with a machine, there's so much that has to be sorted out there, right? You have to differentiate between operator induced. Is it mechanical? Is it electrical? Is it hydraulic? There's all these things that have to be played out, right? And sometimes the troubleshooting process requires action in creating another problem to reduce, or sorry, to eliminate another problem, right? So why I say that, like jumping things out, like I know with CAT machines, if you have an erratic, intermittent, or incorrect code, you can jump out the pins on that sensor and create another code, and that tells you that the circuitry is correct. Right. So there's all these nuanced things and really strategic thinking that is involved to solve a problem. Now, Matt, my question for you is, because you've got 30 years in the space of sensor technology, being a technician yourself, you work for one of the most well-recognized and established sensor companies on the planet, 60 years plus, right? And what is it like for you when you're helping customers with their sensor implementations and all these things, and they ask you, hey, can we just have AI monitor this sensor? Or, hey, what's the process for anomaly detection with your systems? Like, where do you go? How do you go about that?
Well, I think first off, what's your audience, right? So to me, in my opinion, there's three types of users who are throwing around the word wireless AI, machine learning. So you have those who are with very little experience, right, in the CM space, but want to learn, they want to ease in, but they want to have some skin in the game, so they might dip their toes into it a little bit, might have some understanding of it. Then you got those who use it, want to get into it, as I will say, use it the right way to complement a current condition monitoring program, meaning they got subject matter experts, or at least people that somewhat understand the technology that they're using. They have a mission, they have a vision of what to increase that plant reliability. They got somebody in the plant that's going to oversee and understand the tech that they're using and what they're looking to accomplish. And then you have my favorite that I get outspoken on is the those who are forced by a corporate initiative to this whole all-encompassing industry 4.0. I think we were joking the other day that I'm starting to see people on LinkedIn talk about industry 5.0. I think many would agree with me. Most plants that we're walking into, those of us that actually go into these plants, they're lucky if they're at industry 3.5. And you know what I mean? So it's like a corporate initiative by folks who, and don't take this statement the wrong way, but basically by folks who understand nothing of the technology, condition monitoring for that fact, maintenance and reliability best practices, or the equipment, the most important thing, the assets in the plant. Like I said, they just get this corporate initiative and pass it down. So I gotta, I'm no longer in service. Just a correction, I haven't been in it 30 years. Don't age me that much, my friend.
You're old. Come on, man.
You had me confused with Howard. I got 25.
All right, fine. 5 years.
So if somebody comes to me and says, "Hey, Matt, we want wireless sensors and do all this stuff," that's great. I love that technology. I love AI, like we were saying prior to the recording of this. It's just got to be used in the right context, right? That's really what it comes down to. I ask the folks, what their mission is, what we're looking to do. Because listen, I'll end this rant with this. The sensor is only a small portion of a great condition monitoring program. you can stick 1 million sensors on everything and take 1,000 readings a day. That doesn't equate to your plant's going to be ultra reliable. So for me, as I like to say, people who follow any of the stuff that comes on, silly stuff that flies out of my mouth but I always like to say, no one needs more data. You need good, relevant data. You need someone who knows how to interpret that data, whether it's coming from a hardwired sensor or your local service company that's running around with a portable, or you're getting it from a wireless sensor, and they need to know what to do with that information.
Right. 100%. I like the term complement, right? The technology is there to complement the human experience and ensure that there is a way, in my opinion, there's a way to look at a lot of things that a human otherwise wouldn't be able to look at, right? But at the end of the day, the human needs to be, in my opinion, verifying and ensuring that whatever comes from it is in alignment with what the actual goal is. Because we see a lot, even with CMMS and things like that, where people are like, oh, we've got sensors connected to the CMMS. And it's like, that is fantastic. But all you're doing is creating a bunch of work orders that no one can see. And no one has the time to go through. They're not ranked any criticality ranking or anything, right? So you're just creating a whole bunch of data that essentially is useless. Instead of, like what you said, Matt, is go through, take the asset-based approach, verify the context, go through, align with the business, maybe use some AI to aggregate some bigger data into smaller data that can be reviewed by a human, and go from there.
Well, I just want to add one more quick thing. I think a lot of the problem is it's really not just sensor technology. It's two things, right? So you got to kind of differentiate between the sensor and, say, the SaaS companies. And I'm not ripping on them, but that's where a lot of the debate comes in is, are you using the sensor? Is it a subject matter expert in-house, somebody who knows the limitations of the current sensor technology? Or is it somebody who's sticking a sensor on something and sight unseen doing your analysis type of thing? So that comes in. It goes back to your initial question, or what I like to say a lot is, it's not really the tech. The tech's not the problem, even though it is the Wild West, and I think Howard would agree with that. I think the thing right now, the number is just under 200 wireless sensors for vibration. And we all know, that's the low hanging fruit, right, Howard? That's why everybody jumped into that. You only see a handful of wireless in the oil and some of the other techs, but vibration, because that's where the money is. That's the money grab. That's the low hanging fruit. 86% of plants use vibration analysis. So all the tech companies jumped in and started making vibration sensors next to their sensors that chime when you leave your refrigerator door open. Whatever. I'm being silly.
Yeah.
But
you're right. Yeah.
Don't let them find out what Howard does.
A lot of them say, we can do everything. My problem comes in is when some of these companies will say, we can do everything your in-house or outside provider can do with this sensor. And the answer is no, you can't, because going back to what you asked is what they forget. And I think a lot of it's because they're not the ones that say that. I question that they've ever stepped foot in an industrial plant, because you could just walk into a single paper mill and know all the nuances of, say, a calendar section, pressure rolls, Yankee rolls. What about like you said, the phase analysis, run up, coast down, bump test, all that stuff that Howard and I have been doing in the vibration world for decades. All the process issues and different things. A wireless sensor and AI machine learning is never going to do that. It just, I shouldn't say never, but there's just so much other things going on besides just detecting a simple bearing defect or gear fault or something like that. And I'll leave it at that.
But I think you're hitting something on the head, and that's everybody has, instead of looking at condition-based technologies for what they're supposed to be, if you go to AI and machine learning, whichever you want to call it, it's a fault detection method. It's a different type of dummy light. It's not really condition-based testing.
Correct.
Right? It's fault detection or anomaly detection. And really, the technologies come in the strongest. As a matter of fact, I watched a facility or an organization, National Institutes of Health. They hit over 39 million data points per day coming into their 12 data scientists.
It's too much.
And I talked to those guys all the time, but it was, and then when they sat down, they said, what can we use this for? And it's like, well, we use vibration, current signature, and temperature to make decisions on equipment. So we're not going to use it for that. We are going to do is start looking at the big data and figuring out where we can make improvements in the overall process and start using it from a data science standpoint as to make improvements to the system. Otherwise, it's just an anomaly detection system that will say something's not right, or even if they're looking for a specific defect, like a pressure change. Mind you, we had the instance where somebody came in and wanted us to shut down a critical machine because a bearing temperature hit 50,000 degrees. Yeah. People forget that the
Fahrenheit or Celsius?
Yeah.
It didn't matter at that point. We had evaporated.
Yeah.
What the surface of the sun's like 25,000 degrees.
Yeah.
And that we kind of, as soon as that was stated, everybody just sat back and went, wait a minute, what's wrong? Well, it turns out that somebody bumped the sensor and damaged it. And then we had other sensors because people weren't looking at it, they were trusting it, and they let all of the technicians go. I've been to sites where that's occurred, and you go out there and they've got the sensors and they're going, well, we didn't detect anything on the machine. Well, it's possibly because the sensors are sitting on the ground next to the machine, or the batteries failed, or, just a long list of other things. Because the people that have, the understanding of what's going on is going away as well, right? The
Very
more
much.
you rely upon technology to do your work, the dumber you get.
Right. That's right.
I mean, I'm not PC, so
no, it's true, right? I mean, it's
the best you can put it is, in reality, you need the exact opposite. You need people that understand more than they understood before, which includes not just all of the conditions that are possible in the plant, the technology itself, but also what ML or AI is capable of doing, in particular, the specific flavor that you've selected.
Right.
Because it's not just one thing. We put this marketing name around it, but it's a broad sense. Even the sensor types now, as technology advances, the sensors are becoming more and more broad, less capable in some areas, more capable in other areas. And understanding what that data does, says, and means, great. I like the idea of having some of these cool things in my facility, but the idea is, okay, I've got this cool, well, let's just say Spot. I've got Spot running around my facility, taking specific measurements and everything else. And I've got a technician running after him. Oh, the old version, picking him back up every once in a while. But in the meantime, it's taking very specific information, very specific areas, and not watching everything else.
Right. That's right.
So yeah, I've got some benefits from it, but I've got some big negatives from it too.
Right. Well, that's like Matt and I, we were talking last week, and we were talking about how, there's some companies that will recommend failures or failure mechanisms to a client remotely, right?
Yeah.
And Matt made a good point, and he said, if they ever say could be, or you should check because this could be possible, then there's a problem with that statement, because Matt's going to speak to this in a second, because I'm not the expert here, he is. Because if you know bearing type, speed, rotation, like all these things, and you're reading certain amplifications or accelerate, whatever you guys do, you should be able to know this is what's going on. You have an inter-race defect. You have a whatever defect. It's not, oh man, you should probably check this. But the reason I'm saying that is because it takes a human to differentiate and decipher those things.
Literally before our call started, I was there because we had somebody in the field doing electrical signature analysis on an inline fan, motor, belt, fan. And they sent me a set of data. I said, great, it looks like you've got a belt issue and looks like you've got some bearing issues. can you get me this additional information? So they get me the additional information. And then I was able to go back and say, you've got a shiv problem on the fan side. You've got belts loose, slipping, and it's costing you this much in energy. You've got a bad drive-in bearing on the motor. And by the way, one of the pillow block bearings is about to go as well. Well, what do we do? Well, based on this, because they're like, well, we'll loosen up the tension on the belts because it's over tension belts was the issue, right? Because we saw all the patterns that are associated with that. So I said, whatever you do, don't change anything. Why? Well, they said, because we were told that we had, no. If you change it, everything will fail at once. What you want to do is leave everything exactly the way it is. Don't do a lot of starts and stops. How soon can you replace it?
Right.
And he goes, well, what do you mean? I said, it's failed. But a machine learning thing would have said, oh, you got this problem, and not understanding anything, somebody would have gone up and, loosened the belts a little bit, at which point the pillow block bearing would have stopped, would have seized, or something else would have failed, or the belts would have snapped, or, any one of a number of things would have occurred, and they would be suddenly standing there in an outage, versus the background experience I had in that particular type of system is saying, yeah, just don't do anything. Can you shut down over the next couple of weeks, and you're going to have to replace the motor, the belts, the shifts,
Right.
and possibly the shaft.
Right. Yeah,
I was seeing some looseness on it, but that's besides the point. Machine learning would have just identified a problem exists.
Right. Well, that's the point Matt made. And,
Yeah.
Me not being someone who spends a lot of time in the sensor, vibration space, it's like, well, shit, you're right. When someone calls me and says, hey, I've got a rough running condition with my engine.
Yeah.
In my mind, I'm going through all the scenarios that could cause a rough running condition. Not, I don't, it's the transmission. Well, yeah, that could be one, right? But
Yeah.
I have to systematically think through the facts of what could be happening, right? Based on the data that I have. And Matt.
Now, I can turn that around a little bit and say that's actually what machine learning is good at.
Sure.
Yeah. Here's the conditions, here's the possibilities.
Sure.
And then
the difference is when I get there.
Yeah.
And I'm able to actually look at what is happening.
There you go. Exactly.
Right. So Matt, that was your whole point, was if you're not there, if you're not setting foot in the space, if you're not commissioning, taking baseline, setting all those things up, and then you're recommending something that is like I don't want to say a guess, but you're saying, oh, you should probably, might be this, might be that. It's like, well, is it or isn't it? Right? Based on the real data that you're receiving.
Right. And like Howard said about the machine learning part, that is what it does well is, again, I'm a vibration guy. That's my background. So I'll look at that. So like if you have like a running speed fault issue or something like that. Yeah. Very simple, right, Howard? I mean, you could have an ML that says, check all these things that might be associated with that. Our conversation the other day, it made me chuckle because I've seen this as I've gone into plants. I've seen reports that'll say, please verify suspected defect.
That's what it was. Yeah.
Or, it might be this, it might be that. And I had to chuckle because anybody who spent any time as a service guy, and even the in-house guys, people like Howard and I who've been in these plants our whole careers, is if we were to go to a plant manager and say, hey, I need you to shut down this paper machine and lose about $100,000 an hour, and verify that it might have a defect, I'm pretty sure our behinds are going to be bounced out of there within a second. So to me, that was kind of funny. Like in that case, it's like, anybody knows, if you go and you try that and tell somebody to shut down and replace a $30,000 bearing, and it's not exactly on its deathbed, right, Howard? I mean, we know the industries where you go in and they're going to cut it open and they're going to look at that. And if they don't think, you're within whatever of that 5 days, that thing was actually going to fail, it's a bad deal. So those kind of things.
If you say 100 days and it lasts 99 or 101, you were wrong.
Right. Absolutely.
I've literally had people state that.
Oh yeah. So it's like, that kind of stuff cracks me up.
Yeah.
That's wild. Yeah. I mean, that's the thing.
Solution. I mean,
but But
can't
you
just
bring up a
merely
good
suggest
point.
something.
I mean, these technologies, I mean, we use it in what we do, even on energy monitoring. I mean, we have in the cloud side of our solution and in the edge side of the solution, we have alerts that come off of anomaly detection, meaning
Sure.
something has changed. But those alerts are never meant to shut something down or say there's absolutely a problem. Because I always get a charge out of like a lot of what I do with electrical signature analysis. Oh, a system has to train for a week. Great. It's trained to that electrical environment for that week.
Right.
And now anything changes. Somebody changes the light bulb. Somebody adds something else to the circuit. Somebody turns on a set of single phase systems that weren't there before. All of a sudden, an anomaly alert comes up.
Yeah.
You know, anything that changes outside of that training, the system doesn't understand. So we'll put it in, and the sole purpose is to trigger us to outside of our normal review of data or trending of data to say, okay, something small has occurred that's not showing up in a trend. It might be an issue, it might not be an issue. You know, hey, prompt, hey, go take a look at it. And then you go and you look at it and you say, oh, okay, well, you know, somebody in the neighborhood must have turned on their air conditioning. And so there was the voltage sagged a little bit and then came back up again. Or like we did in one case, holy cow, they've got a 69 kV line failing in the distribution system. We need to get a hold of somebody fast before it takes out the plant.
Yeah.
And we've done that. But the idea is that's where machine learning and AI is important right now. Okay. Eventually, well, let's just say Vibration Institute a couple of years ago, I was there, and during a presentation, they were talking about detecting one type of fault in a bearing. And they needed using now this is fault detection, meaning identifying what the fault is, because you never use deep learning or neural networks is not a time-based system, right? So you can't use it for that, but you can use it for classification, meaning identifying something. It took them 2 million training points for that particular type of fault, which was just outer race wear in a bearing. They had to do all this other conversion. But if the bearing had shifted in the housing a little bit, which we all know happens when they start to fail that way, it would have gone back to good.
Yeah.
That was actually my question during the presentation. What happens if the bearing shift? Well, no, bearings are static. No, they're not.
No, they're not. No,
Trust me, I'm taking them out. You see all the marks around the outside of the bearing because as it fails in that method, the outer race starts to move in the housing. But it took 2 million found data points to create something that would identify that defect.
And how fast do you think someone like Matt would pick up that defect?
Oh, either he or I would have picked that up immediately. First reading, outer race defect. It's if it's vibration or shock pulse, right? You would have seen certain readings that would indicate the severity. In ESA, we'd see so much energy lost,
Sure.
right? So either way, we would have an immediate one-off answer, meaning we don't have to have any training. It's boom, there it is.
Right.
The experience helps if somebody says, how long is it going to last? And then you have to take into account a bunch of other things, which data helps. But,
right.
Every time somebody tells me rule, I start to laugh because you know what rule is, right? It's literally mean time to failure.
Yeah.
Average time to failure. Yeah. It's not actually time to failure estimation or predictive anything, but they're using it. And everybody learned off the same set of NASA engine data sets that everybody else learned off of, right? That same data set that's available since forever.
Right.
So that's one of the key things is as you mentioned, the sensor data on a human being based on our knowledge of the systems pops up immediately.
Right.
And the other technologies, the AI and machine learning isn't quite there yet. They claim to be, but even in the EPRI study that was done in 2020, well, it was done over 2020, but finally got published at the end of 2021, machine learning was way at the bottom.
Wait, just
compared
think,
to expert systems.
think about like, you know, anomaly detection, right?
Yeah.
And it's another thing, like it can make it, say it makes a great anomaly detection reference or identification, right?
Yeah.
Who's going to fix it?
Well, there's that too. Yeah. Yeah.
Right.
Sorry. My data will run out and fix that. You know, my machine learning on my laptop is going to go fix that bearing, right?
And there's a massive distinction I've found in
Yep.
being able to identify a problem and actually correct the problem correctly and the first time and do it right. Right. There's a lot of,
the key.
what's that?
That's the key. Fix the problem correctly.
Exactly. So like, it's really easy to say, oh, this thing's got an inter-race bearing defect. Thanks. Thank you.
Yep.
Now what?
Yeah.
Right.
What caused it? How do I prevent it from happening again?
Well,
So
that's a big, I just want to interject, how many times, I don't know how many times where I've been called in on special calls, non-route based type stuff, been called in and without a human being there, to have that interaction between vibration professional, condition monitoring professional, and then relating that information to the maintenance people and having the conversations with the millwrights or the electricians and being able to ask almost like typical, investigative type of questions. Like,
yes.
when did this start? How long has this been going on? This has been a thing, getting that information that AI is not going to be able to do. Like I said, I'm with Howard. I love AI. I love anomaly detection as long as the terms are used in the correct use, but there are still, you can't get away from it. Cause like I said, you got to have that interaction with machinery. AI and other industries, yeah, maybe it'll take over, but in ours, I think there really has to be that human interaction of having the conversations
Right.
to dig in and to collaborate.
Right. And then, I wanted to switch gears just a little bit, which is, there's a big thing now, and Upkeep has it as well, which is, AI generated checklists for inspecting machinery, right? Or creating some form of inspection or PM or whatever, right? And there is some value in those things, and I think that they're a good starting point for someone who may otherwise not have a good understanding of what they should be doing in the process of inspecting or establishing a baseline of a particular machine or asset. So I do think that, but what I will say is I think that those types of things need to be, if you're going to really trust them and you're not just using it as a starting point to kind of get your bearings, they need to be vetted by someone who knows.
Yeah.
They must be vetted by somebody who knows context, operating context, environment, age, all the things that go into how you maintain something or inspect something. What do you think?
I absolutely agree. As a matter of fact, the MotorDoc AI is our research division, right? And it's specifically, we utilize a lot of AI, whether they're models we build or we even use, say ChatGPT-4 or some of the research tools that are now available there. The idea is you can go in now and you can knock out a lot of stuff and identify things you hadn't thought of before. But you're absolutely right. You have to vet it. And part of the reason why is because when we just watched this happen, you have to remember that we'll say the ChatGPT-4, the big, large learning model that everybody got excited about, is 1 year and 3 months old.
My boots are older than that.
Yeah, 1 month and it's 1 year and 3 months old. During that time, they went from just over 80% accurate to 14, then back close to, and each time they had to retrain the thing because it started getting false information in, and it built on the false information. And it took the end users to come back and say, hey, folks, we're getting less working. A third party started identifying every time it became inaccurate. This is not something that, is a secret. It is documented. They talk about it in news stories and everybody carefully ignores this stuff. But I remember that because we were doing some programming and I said, okay, we need to rely upon this because we're at 2,000 lines of code. So we're relying on this to help us out. And it started getting really inaccurate. It's like, that doesn't make any sense. This doesn't make any sense. So we had to go back and kind of relook at everything. Or in some work I was doing research, looking at research papers. It's great for going now, especially going into PDF research papers. There's whole libraries are built around it. And they'll go through and they'll pick out the data and then cite where the source is so you can go and physically look at it. Well, it saves me going through hundreds of research papers to do the paper side of the research project.
Right.
And then shortens that time up, or even sometimes identifies things that we hadn't even thought of. That same thing happens there. So it can help you on the checklist say, hey, these are the things that we missed. But to rely on it fully, I had a company send me their safety program. And I called them up and said, you just had this produced off of an AI, didn't you? They go, they denied it at first. And I go, well, if I followed your safety program, I'd be dead. And here's why. And it had inserted things. It would have had me putting my bare hands in 13.8.
Oh, that's a problem for you.
Yeah,
You're
not
good.
a problem at all. You don't require PPE for this. It's a 13,000 volt system. Well, it didn't recognize 13,000 volts. It only knew 480, right? So, it was like, okay, yeah, this isn't going to work. So yeah, somebody who's knowledgeable should be following behind and vetting that information. Absolutely.
Yeah, it's
But
so
the
important.
shortcut to get there, that time saved doing the work in between is really good, because then you've got basically a template and then somebody going through it saying, no, yes. Oh, we forgot this,
Yes.
And then you end up shortening up the time. I mean, that's what we found. I mean, it used to take me, I just wrote a paper for a conference. Would have taken me a couple of months to write the paper and finish up the research end of it, all the references. Took me a weekend.
Man, just think about all the powerlifting you could have done in that time, man.
And and then doing helping with an M&V thing, a measurement and verification of an energy study. Went through and did the data science and used machine learning to help identify areas we hadn't thought of. And there were huge opportunities that came out about it from it. And with the background of the folks involved, they were able to go, oh yeah, we could do this and this and this to make additional improvements. So there's a power to it when it's working off of good data. But at the same time, we were saying, yeah, that doesn't make any sense. And no, that doesn't make any sense. And yeah, somebody probably wrote that in a book, but that doesn't make any sense.
Yeah, I mean, I think
without the human background,
right,
in those areas, the expertise, you end up with garbage.
Right. And that's what I'm saying. Like, Greg Christensen and I were talking, like, I don't know, a year ago about the ChatGPT thing and all that, and like the inspections. And I was fooling around with it. And I would say, hey, rate me a 500-hour service on a Cat 777 haul truck. And half of it was like, what? Like, no, you don't have to do that, right? It makes no sense, right? But if someone who doesn't know anything about 777 haul trucks asked that question, it would give them a foundation to a point, right? And then they should look to somebody who does know, and then they go through and they go, this was good, this was not good, this was good. No, you don't need to do that. This is condition-based, blah, 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 blah. My last thing is for you, Matt, which is, correct me if I'm wrong. I don't know. I haven't tried. I'm not tech savvy enough. Is there anything out there from a machine learning AI standpoint that allows you to set up the most effective or efficient route to take on a condition-based maintenance inspection? Like, so for instance, are you able to take a blueprint and import it into something that shows where all your assets are, and then it make the most efficient route and what to look for on those?
I'm going to say, yeah, there probably is, but would I ever use it? Hell no. Simply because I think Howard was kind of alluding to this before. Some of the stuff's great, but I think people forget about where it's not needed and how it's more of a time suck than it is how it helps. I mean, if you can't walk a plant when you're doing a quote or something like that and figure it out, if you need AI to do that, you need to find something else to be doing for a career. I guess that's my non-PC answer. I would say no. You know, I think a lot of times, you know, there's a say, you know, right? People will pay for what they want, not for what they need. You know, I think condition monitoring with the marketing out there is being a lot of times marketed as an easy button. And, you know, and as the old saying goes, the easy way is rarely the best way. And I think that still holds true in our beloved condition monitoring space at this time.
It's the same for CMMS too. It's always sold as a silver bullet.
You know, at my last conference, I called it, you know, the diet pill approach to condition monitoring, where people just want to take a pill and not have to work out or run or, you know, eat right or whatever, you know. Again, you know, I always, going back to what you asked about how I approach people in a plant, you know, I always tell folks, you know, if you're not familiar with condition monitoring and somebody approaches you and says, you know, we got the silver bullet, we got this magic cure all for your plant, then I would either run as fast as you can or call up somebody who's been in the space to help you vet that out and see what the limitations are and what you can do. Because a lot of times I've been noticing, which is frustrating to me, in the sense that, you know, when I used to do a lot of quoting and stuff and gets a little bit of pushback from time to time, I look back on those quotes of what I was paying or what I was charging. Let's say like maybe $5 a bearing or something. And now I look at a lot of these companies that are charging with a sensor over 100, 150 a point. And I'm like, and there's no outcry on any of them.
Nah, man, it's sensors. It's predictive. It's going to eliminate all your downtime.
I'm like, the cost stuff. I'm like, does anybody think of cost anymore? I mean, I remember a day when cost used to be the #1 driving factor. Now it's like, oh, I don't need to look at it, or we don't have to have people to do this. And I'm like, well, we'll have a conversation in a couple of years
again. Yeah. And very few people pay attention to that. It's the same as the folks are saying, well, we're going to AI and machine learning and cloud-based systems to reduce our carbon footprint. And I start laughing because we do a lot of data center work. And I know how much energy it takes per gigabyte of data processed. And you are doing quite the opposite.
Or did I actually, I laughed so hard, like I almost just fell out of my chair because we had this conversation.
Yeah.
You know, I had mentioned that in one of my presentations at a conference. I said, you know, for all you companies out there using the environment as a marketing tool, just stop. You know, I only know one guy that can actually quantify that, figure that out, and that's Howard with his stuff. But for people to say like it's a lower carbon footprint, so I had to text my guy and say, hey, is it true that this percentage is what's getting pulled off the grid with cloud computing and all these IoT batteries? And he's like, no. I said, oh, is it high? He's like, no, you're about 10% low. He's like, here's what's really getting drawn off. You know, here's how many tons, how many millions of batteries get landfilled every day from IoT. I'm not just saying wireless vibration sensors. I'm saying IoT in general. You know, it's
the project you and I just have talked about recently, the one I'm doing on relating energy losses to vibration as well. A lot of the reference papers I have to go to is the ones where they scrape energy off of the vibration itself to charge the sensor. So what I discovered is the values that they're using require your system to be faulty in order for them to charge themselves.
Right.
Yeah. You have to have a certain level of vibration in order to charge some of these things.
Yeah, I've seen that.
Yeah.
That's wild.
Yeah. It's so wild. It's pretty interesting.
But fellas, you know, we're at time over, like always. That's how we do. But it's been awesome. Like I said, I just wanted to have you guys on and just talk through some reality of sensor AI. And, you know, we're not bashing it. We're not anything, right? Quite the contrary. We just want to put it in a context that is relatable, and get to what the reality of it is and the reality of how it's utilized and things like that. And like I said, we at Upkeep, you know, we pride ourselves on our AI generated checklist, and we even market it as such where it's a starting point, right? We're not saying this is a silver bullet. We're saying this is a way for you to gain some ground with with some limited experience, limited expertise, but we also have the ability to give the customer that expertise should they need it, right? And that's one thing where others do not have. So I just want to thank both of you again for coming on. I will see you guys soon, and it's been great, and I really appreciate it, and thank you.
Absolutely.
See you in a few months down in Chicago.
Yeah,
There you go.
right on. All right, fellas. So this has been Upkeep Pledge Pros podcast. Howard and Matt, thanks, fellas, and we'll see you on the next one.
See you, boys.